Hello guys, welcome to another video about Houdini. In this one, we are going to use Houdini to create a spider web. Okay, so from time to time, you probably will have situations that you wanted to make something that seems to be hard to do manually. But it does have some rules that you can see, like a spider web. Basically, it's kind of like a bunch of circles with lines connected to the center, right? So even we cannot get like exactly the final result, but with some procedural ways, we can get something really close. And that's oftentimes gonna save us a lot of time already. And more importantly, you can make a lot of variations down the way, right? So that's when procedural workflow becomes really valuable. Okay, and so yeah, let's try to adapt to some of the ideas here that we can do with Houdini to achieve like a spider web today. Okay, so we can go start with a geometry. Okay, and then open it, and then we create a line. Right. Want this line to be flattened, laying down on the ground. Okay, so I'm gonna go for a z direction line like this. All right. I also want it to be longer, 10 units long. Okay, and then I can create a bunch of points. Doesn't matter how many. Okay, and then another circle. Now this circle will also be flattened on the ground, so that's going to be the x-plane and polygon. Okay, and let's see what else do we want. Well, it doesn't matter how many lines you want, you can just have more or less. Okay, and then what we do is we copy stamp the curve or the line here to the circle. Now we're getting this. Okay, now that's not looking very nice, so we kind of want it to be flattened this way. Okay, in that case, we can redefine the normal direction to be facing away from the center. Okay, so what we can do is we can do a attribute wrangle here and say at normal will be basically their position. Okay, you can see now how they're basically facing outwards. Okay, so this is vex coding, right? What it does is basically using scripting way to define different attributes of anything like point, primitive, or versus whatever, or details. Okay, so what this does is basically saying the normal of the point will equals to the position of the point at means attribute of, right? The attribute normal equals to the attribute position. Okay, you can also visualize that if we grab this guy and take a look at the normal direction, you can see they're facing outwards, right? While this one was facing down. All right, fantastic. So afterwards, we can go here and say, all right, how about then we connect lines between those dots? Okay, but because there are a lot of dots here, it's harder to connect them without any help of knowing like which one belongs to which ring here. So let's actually create another wrangle node, attribute wrangle. Just tab and then AW for attribute wrangle here. We're gonna say at ID, at ID, meaning we're creating an integer attribute called ID, and that can be equals to the position, not position anymore, the point number. Okay, every point has a number. Okay, as you can see here, if you take a look at the points with the number visualized, you can see now they're numbering from 0 to 16. Okay, the attribute wrangle will basically say their ID is also equal to the point number. Okay, we can then visualize that by hitting the D button in the viewport and say visualize, and then we can go create a new one, marker. We can call this guy ID for the name and label. Attribute will also be ID. and it's going to be of the type point or of the class point. Okay. Just to be able to visualize it better, we can make it like a red color. Okay, you can see now we have those red values. They're now currently the same as the blue point number values. Okay, but then after combining, you can see, well, they're also following that order, right? So the first ring will be 0, a second ring will be 1, and third ring will be 2, so on and so forth, all the way to 16. All right, and then we're gonna go pipe it through a for loop for each number. Okay, and then I need to know how much I need to loop through, right? I want to loop through every ring, right? The ring 0 and 1 and 2, connect them together, make some variations. So I need to know how many rings I'm having. Now I can see there's 17 rings, right? But how can I even know that with the coding? Because sometimes maybe I went to the lines and changed it to like 9 points, then the value should be different. So it's not ideal to have a fixed number here, say 9 or something. So in that case, we need to know what's the maximum number here for the rings, right? And there is a node called attribute promote. Attribute promote. Attribute promote. Okay. Connect that over here and that over to the beginning of the for each loop. Okay. For this node, we're gonna say we're gonna we're gonna promote the value ID, right, to the detail class. Detail class will be the detail attribute of any object. If you go for split the panel to top and bottom, and change the scene view to geometry spreadsheet, and go to the details, you can see, well, the number is 4. So we're basically promoting a value. Before it was having nothing, right? Now it does have an ID value of 4. Now why it is 4? Because it's using the average, right? For point, every point has an ID, but for detail there will be only one attribute, right? There's a lot of points, a lot of vertices, and a lot of polygons, but it doesn't have a lot of details. This detail will only have one, and so it's promoting by calculating the average, which is not what I need. I need the maximum. Okay. I don't want to delete the original. I still want to have the ID here. If I check delete original, you can see those ID goes away. I'm going to change this new attribute from ID, which is what it's having now. I'm going to change that to max ID. You can see now we have this max ID and its value is 8. Great. Now I know I need to loop 8 plus 1 because the index of the range started with 0, so it's going to be the max ID plus 1. Okay, so let's rename these guys. I'm going to call this guy populate ring begin. Right. Copy that and then count, and this is end. When I say you are going to iterate the max ID amount of iterations plus 1, right? So to do that, I need to know whatever that is connected to this guy. I need to know its detail attribute of ID. So we can do that with coding. We can say, okay, this iteration will be equals to the detail attribute of the operator input pass of the .. meaning that whatever this node is, instead of it, we're going to look for this populate begin. I'm asking for this guy's first input. Okay, 0 means the first one. We're gonna ask for the attribute of max ID. Okay, and then we're gonna ask for the first index of that attribute. The reason we need to have the 0 here is just for the pure purpose of consistent signature for the function. Max ID is a integer value, so it doesn't have any multiple components. But there could be an attribute which is of the type vector, like a position or a color. You have RGB or XYZ 3 channels or 3 components of that particular data type. Then you have to specify an index basically, but 0 is basically all we have to do. Just, There's no other. All right, enter. And you can see now if you click on this to see the result of the evaluation, you can see that's 8, right? Now, just like what I said before, it cannot be just 8. It has to be 8 plus 1 because our index is, starting from 0. Now the result will be 9. The beautiful thing about this is that you can always go back here and say, okay, I'm having more rings. This will do more. This will also do more here, like 21 now. Okay, which I don't need that much. So let's go back to, I don't know, maybe just 11 should be fun here. Cool. All right. Now inside of it, I'm gonna do a blast. Okay. And for every iteration, I want to work on one ring and delete the others. So this blast will get rid of everything else but the ring that has the same ID number as the current iteration number. That number is actually over here. And take a look at the value here. You can see the iteration is 20. If you go here to the end and check on single pass, which will run every individual loop, if the single pass is 3, you can see now the iteration value is 3, right? So every time when it runs through the loop, the iteration will increment, right? So all we have to do is say the ID will have to be equals to the value, detail value, because it is the detail value of this guy, right? So to say equals to the detail value of, again, dot / and then populate count, right? This guy's iteration value, and again you need to specify an index. Now be aware that I have this backtit wrapping around detail. That's just the way it does this. Actually, this is exactly like Maya. Backtit to evaluate what's in there first, and then compare that result of the ID. Right. So if you do this and run this, you can see where one ring disappeared, right? Because we're deleting that ring. Now let's go ahead and change that to point actually. Yeah, that's actually deleting a ring here. You can see that ring goes away because that ring is of the value of 4, and we're currently on the loop, on the iteration of 4, right? If we go ahead and change that to like different single passes, you can see we're deleting different rings. All right. So of course I want to delete the others, right? So delete non-selected, and that's going to give me every individual rings, which is fantastic. All right, cool. So now I wanted to connect them together. Now luckily, if you take a look at the point number here, they are ranging from 0, 1, 2, 3 all the way around in a very perfectly aligned circular order. So that means we can do this add node and go to polygons and by group. Okay, now if you take a look at this guy's result by clicking on this visualize marker here, you can see how it's connecting, and we can check on closed to finish that. But again, I don't want the face, so I'm gonna go for a convert line node. That's gonna convert it into just lines. All right, fantastic. So after this, if you go here and check off the single pass so that it's running on everything now, you can see we're connecting the rings. But now we look at it, it's too regular, and it's all evenly spaced, so that's not realistic. In this case, we're going to create a attribute wrangle here to vary their location. Okay, so we can say add position plus equals to the current position, right? And we normalize it. Now if we normalize its current position, everyone's position is basically an arrow pointing from the origin to them, which is the perfect direction to go outwards. Normalize it gives you the unit vector of that direction, right? We add that much times a random number from maybe a channel called seed, and for every point, just to make the seed different, we can say we add the point number, okay? And then also to make it different for every ring, we can add the current ring number or the current iteration. Right, we can say detail. And this time let's do the second input, iteration. It's iteration. Iteration should be the word. And then 0. Okay. Right. And then, well, there's no second input, right? So let's connect that. Let's connect that to the second input. You can see now how they're getting different. Okay. All right. Now that's harder to control. I wanted to be able to control how much we're going for. So we can say, let's fit this result, because the random value will be from 0 to 1 when you do rand. Let's fit that 0 to 1 range from that value, right, to a negative channel offset, right, and to positive channel offset. Okay, run this. You can see, well, their control enter to run this, right? You can see, well, they're going back to 0 because then the channel offset, if you don't do anything, it's going to be 0. If you want to define the channel offset, you just need to click on this create, and that's going to create the channels we created in the node. So seed and offset. Drag offset up, you can see now how much we're offsetting those lines, and seed can give you different variations. Alright, cool. Maybe go back a little bit. Alright. I think this is too perfectly circular-like. I think I don't need that much. So I'm going to lower down the division to have lesser. Maybe 12 is okay. Right, you can see how it's non-destructive. Whatever I change in the previous stages will carry over without any problem, right? Cool, now we have all these lines. Okay, let me disable the visibility of the ID. And we can also disable the visibility of the point. Right, let me drag this out, holding down Alt button to click to create a reroute node, and again there. And again here. Oh, we cannot do that actually if you don't end up with anything. So yeah, then we can create a merge to merge this guy's final result to this guy. Now we're having this. Okay. Well, it's close to a spider web, but it's having some major issues. First of all, those ones are not in the origin. Okay. And the other guys are kind of like, you know, not extending out enough. Okay, for this last one, what we can do is actually if we don't do the last loop, then it'll be fun, right? So yeah, that's gonna be an easy route for that. Okay, for the middle ones, however, we kind of wanted to extend over. Okay, all right. So in this case, I actually wanted to add just one more point to the center, and just connect all these guys over here. Okay, so I'm gonna say attribute rango here. No, actually just attribute rango in here and just put it in the middle. Okay, it's gonna automatically connect, which is cool. Yeah, I think Substance Designer should learn from this. And reroute node, how hard is doing that? Like the reroute in Substance Designer is crap, really crap. Anyway, so yeah, what do we do? Yeah, we add a point in the middle. So for every line, I guess we can loop through the let's take a look at the points. Okay, well, what we have to do is this. I'm gonna say if the ID will be equals to 0, right? That's all the points here, right? Because those guys are ID 0s if you take a look at the IDs, right? I just need to add another point. Okay. So int new point will be add, and we're adding it to the geometry. 0 means the first input, basically it's our geometry. Position will be basically the origin, so set 0 0 0, or maybe just curly bracket 0 0 0. Okay, and that should add oh, add point, not add. That's gonna add a bunch of points here. Okay, you can see their index is actually -1, which is cool. Anyway, and then we can then connect those guys, right? So we create polygons. So we can say add prim. And we're adding the primitive to the first input, and then it's gonna be a polyline. And then it's going to be from the current point to the new point. Okay, this add point will yield the new point number as will return the new point number. So we pass in the point numbers of those 2 points, and this add primitive will add a polyline between those 2 points. Okay, as you can see here. Okay. And just to be safe though, I want to set those guys to -1, although they're -1 actually, which is interesting. I don't know how it does that. So you can say, okay, now set point attribute of the first geometry, right? And the attribute will be ID, and then it's going to be of the for the new point we just created, the value will be -1. Let's try -2. Yeah, it's just to make sure that we're setting it properly. So we're basically closing the middle. All right, cool. But if you take a look at this closely, you can see, well, there's a problem. But those lines and these lines on the edge, they're not in the same position. And so that's kind of like, a major issue, right? So we kind of wanted to match them there. All right. So to be able to achieve that, we can do another wrangle node. Okay. We can actually match based on those rings. Let's connect the result of the rings to the second input of the wrangle node. Okay, take a look at that, what those lines are looking like. Right. So all we have to do is find the points around, like for example this point. All we have to do is find around it and see if there is another point, and also make sure that that point has the same index, same ID basically. Right, and then we can just move this point to that point location. Okay, so we're gonna say int points nearby equals to point cloud find, and we're finding from the second input. We're finding based on the location, so P as position. And we're finding based on our position at P. We're finding around a radius of 1. We're getting only 1. Okay, so this will find anything within the radius of 1 unit away from the position of our current point. We're running over for every point, right? If we do find some, then we just need the first one, and the first one is according to the documentation, will be the closest one, which will be like if I find all these, or the closest one will be the one that's getting captured, which is going to be this one. Okay, so we're gonna go check this. If at position, if at ID will be equals to the same ID as that one. So, you know what? I need to know the ID then. We do this. If the length of this new thing, we capture this new list of points. If that guy's length, meaning how many elements it does have, is bigger than 0, basically, that means we're having, more. We found something, right? In theory, we should find something very easily because their distance is not supposed to be bigger than 1, because this is actually a distance of 1, right? So they are not going to be too far. Okay. All right. And we can say, okay, if that, and then we're going to compare their ID. So we can say int other ID will be equals to points nearby. It's first one, right? We're going to ask for this point ID, so we can call the point function first input, again, the ID attribute of this point, right? This is gonna give us the point number, right? This returns the list of point numbers we found from the second input, which is this guy, right? Those circular shapes. Okay, right? Let's see if the ID is the same, right? So if at ID will equals to the other ID, then we're sure that that's the point that we wanted to snap to. So we can say vector position will be equals to the position of that point. So we're asking for the P attribute, which is position of this guy, right? So what is your position? And then our position will be equals to that position. Run this. You can see how they're now snapped, right? So now you can see all the lines from those, concentrating lines are now merged properly. Not merged, but moved to that area. Okay. All right. Now this may have some flaws. Let's take a look at that. If I go ahead and then offset too far away. Yeah, when it reaches too far away, it's gonna have that problem, but only when it's too far away. So I think we're okay. We don't really go that far anyways. Right? Cool. So yeah. Anyway, so when that is done, then we do one more thing, which is fuse all the points together. Okay, so that way all the points are kind of like combined into one point if they're overlapping on top of each other. Cool. Now basically we're having a web now, okay? But if you're happy with this, you can just use this now, right? It's perfect. It's a web shape. But we could do more, like, in reality the web is kind of like dripping down, right? So we kind of wanted to do that. Okay. But what I want to happen is that when the web is dripping down, of course, those ones that are holding the web will actually stick there. So I need to know those points and make them stick. Okay, and those are easy because you take a look at the ID. That's going to be the ones with the ID value of 10, right? So we do another wrangle node and say, okay, for all the points, if at ID equals to 10, then what we do is and say I at glue to animation equals to 1. Okay. If you take a look at the points here, you can see, well, there's some point that does have this value glue to animation to be the value of 1, which is the ones that are on the far outside. The others are not glued to animation. Okay. This attribute is a known attribute for the dynamics. Let me create a null node so that it is kind of say it's nothing, right? It's just passing along, and you can give this guy a name, web for stem. Okay. Now just to have some fun, we can grab this and create a transformation node. So tilt this guy a little bit. Okay. If you grab this transformation, go to the viewport and hit enter button, you can then rotate it. All right. So we have this tilted web. Okay. And turn off that and turn off that. Okay. Now let's just make this web dripping down by simulation. So we do a dot network, dynamic operator network. Okay. And then go inside of it, we need to get in the thing. So we are simulating with wire solvers. So we need a wire object, and we just load that null node called the web for sim and accept that and pass it over to a wire solver to solve it or simulate with that solver. And we need a gravity force to drip it down, and that goes to here. Okay, now back here to the outside, we can go back to frame 1 and simulate. You can see now how it's dripping down nicely. It's having a lot of elasticity, but it's doing the job. Okay, but then you can see, well, it is cool and all, but they're too straight, right? Those are really straight lines. Well, that's obviously gonna happen because your lines here, if you take a look at the lines, we don't even need to see these. If you take a look at the lines, they all consist of just 2 points, right? Of course, there's no way for it to bend, Okay, in this case, then we have to do something to make it bend. Okay. All right, so to do that, let's create an attribute wrangle node. Oh, actually, we don't need to do that. A resample would be sufficient. Okay, like that and that. Let's take a look. Now this resample will resample everything. Okay, we're gonna resample for by polygon edge, so every edge is resampled the same way. Okay, and then also we need to do another fuse because resample could break the points. All right. Now let's take a look at our results. Get back here to frame 1 again. Don't want to see all the dots. And simulate. Cool, you can see now how they're able to drip down like that. Pretty cool. Now we have this web that is really dripping down like this. Okay. Well, of course, it's kind of like getting a low performance. Well, that makes sense because we have a lot of points. So I'll go back to frame 1. We can say, okay, that's too much for you to handle. So let's go ahead and lower down the poly count. I don't really need that much. Maybe the length can be higher, like 0.4. 0.4 is too small, like 0.2. 0.3 maybe. Right, because we don't really have to have a lot of resolution. We can smooth this guy out later on. Right, so it's not that necessary to simulate a whole lot of points. Right, you can see now it's faster this time. Okay. And after the simulation, when those things are all becoming blue, that means, yeah, they're simulated. Right, they're good to go. So one thing we could do is, well, there's something here that is actually, you know, a little bit automatic. Here you can see we defined the glue here for the last point, but these points are all glued, those two, because they're the ones that's really close to the original point. When you resample, they're kind of like copying the value over to adjacent points. So this point could inherit also glue to animation. You know what? This is actually not inherited. So yeah, that's still this point, which is cool actually. Okay, but otherwise you have to attribute wrangle to get it work again by using point cloud search. But anyway, this is working, so I don't think we need to spend enough more effort on that. Okay, but I do want to simulate more frames, so I'm going to go to the time range settings and say, okay, let's go for 1,000 frames. Apply that. Okay, so now we can keep simulating until it becomes stable. Turn up the points. Yeah, that's good enough to me. Okay, of course, if you wanted to say, okay, I wanted to, you know, be more loose, you can go to the dot network and grab the where object and go to the material and elasticity and plasticity. Those things are the physical attributes, right? If you don't want it to be able to stretch that much, you can make it harder to stretch, right? So the threshold can be higher. That's actually easier to stretch. Sorry about that. Or is it? Let's change that to something lower. Not that much of a difference. So I guess it's fun. Let's go to the elasticity here. I'm gonna say the linear angular spring constant. That's controlling like how easy it is to bend. So if we go ahead and run this again, you can see it's easier to make arcs basically. It's not gonna produce a whole lot of differences because we have fewer points in there, but this should be enough, right? Okay, just wait for it to settle down and stop this. Cool. Now, of course, this is just a line, so that's not ideal, right? We wanted to actually create a geometry, so we can then go path it through a wire, polywire, to convert it into geometry. Okay. Whoa. Don't want to see that. Now they're all geometry. Then we can change the wear radius to make it thicker or thinner. We can change the division to have more subdivision levels here in the middle to make it more rounded, right? Okay. We can do some smooth. It doesn't really help actually. Do the segment to smooth it out more. You know, that doesn't really help because they're adding segments, but they're not rounding it up. So that's not good. We probably need to just smooth this guy if we want it to be more smooth. But again, I think this is smooth enough anyways. All right, so yeah, that's basically a a quick view of how you could done it. But again, this is too generic. That this is kind of like a web that's perfectly circular in the beginning. If you look at the real web, it has different anchor points, right? So this is just like the basic idea on how you can achieve this, and some exercises on different aspects of procedural modeling. A lot of things we didn't do here is like the renaming, right? We don't name any nodes properly. Like maybe just this one we named it, but you can say this one is the dripping, right? This is wiring, extrusion, right? And this is going to be tilting, right? This is merging together. Resample, we can call this guy at middle points, right? And what this guy is, oh, add glue attribute, right? So one thing beginners doesn't do is name their stuff. It seems to be easy in the beginning, and it is easy, but you will pay for it miserably in the future if you don't name your stuff, because it is guaranteed that you will forget what you're doing here. Now, if you see the name, you can easily assume what it does, right? And by looking at it, you can confirm it. Otherwise, it's really hard to know what's going on. This field is not needed. You can delete that. Okay. Oh, actually, I think you need that because it is needed for the resample. Yeah, that's correct. We need to fuse it and merge, right? So yeah, name your stuff. Like, what does this guy do? Oh, add center point. Oh, point. Okay, renaming all your nodes that you think that's at least important. I think every node here is important. So yeah, match dots, match point position. Okay, and get max ID number. Okay, yeah, those are simple. You don't have to explain these. I think those are, but this one should be added to the add the attribute. Okay, yeah, you can see now we're naming all those things together now, and we got, a much easier to understand graph. Okay, so many artists start learning this procedural workflow, but forget to really try to organize and rename their stuff, and more importantly, refactoring sometimes. Like, you could do this way, right? And there could be other ways, and there could be easier ways than this. It's never set into stone. So when you have achieved something, basically in a programmer's point of view, I just achieved it. I'm far from making it perfect, right? I could rethink of this workflow and think, okay, if there's an easier way to do this, maybe I should try that, because that gives you better performance, make it easier and cleaner to understand, right? So the first try, this is actually my first try on this, right? This could be the bad way of doing this, but many artists doesn't really try further. And that's what's separating like the way of thinking of an artist to a real engineer, right? You want it to be able to say, okay, my workflow here is the best I can think of, right? I'm sure that it's going to give me the best result and the easiest workflow, right? So this is just the beginning, and you can really think about like, maybe I can create those lines first, and then I can connect those lines in between. Maybe there is a better way of doing this. That's what we call refactoring, right? And it's in rare cases, like in programming especially, when you have some idea, you achieve it, coding wise, that coding way you invented in the beginning is going to be the best way. It's rarely happens. So there is always a better way sometimes, and you wanted to think about it. Okay, so yeah. All right, that's it for the spider web creating workflow, right? Yeah, I think this could be actually uh, a good practice for beginners. If you just started like learning procedural workflow, right? This maybe can give you some insight on how it works, right? And some basic ideas on how should you work on this. Okay. All right, cool. Thanks for watching. See you next time.